Okay, this is Chapter 9, Lesson 6. We are on P166 now. We're on the back side of that homework page. All right, let's look at number 1. In a fish tank, 2/10 of the fish were orange and 5/100ths of the fish were striped. What fraction of the fish were orange or striped? That means both. We're including the orange and the striped. So another way of saying that is addition. We're going to be adding those. So we're going to be adding the orange, which was 2/10, plus the striped, which was 5/100ths. So again, it's just like the front side. We need to change this tenths to a fraction, to an equivalent fraction with a denominator of 100. And you're going to have to do that by multiplying the numerator and the denominator by 10. 10 times 10 equals 100. 2 times 10 equals 20. So now we have 20 tenths for 2/10. We change that 2/10. We change the 2/10 into 20/10. Those are equivalent to each other. And now we can add straight across. Denominator stays the same. 20 plus 5, 25/100ths. Okay. Number 2, Greg spends 45 cents on an eraser, and that tells us we're adding 30 cents on a pen. How much money does Greg spend? So he spent 45 cents. We're going to write that as a decimal. And then 30 cents, and again, the key here is lining up your place values. So in 45 cents, we have a 0 in the ones place. In 30 cents, we also have a 0 in the ones place. Then our decimal. Then in the tenths place, there's a 3. And in the hundreds place, there's a 0. Okay, now I can add these up. 5/100ths plus 0/100ths is 5/100ths. 4/10 plus 3/10 is 7/10. Bring my decimal straight down, and 0 plus 0 is 0. And again, we're dealing with money, so 75 cents. All right, let's look at number 3. Philip saves $8 each month. How many months will it take him to save at least $60? Okay, so we can just start writing months. So in the first month, he saves $8. In the second month, he saves another $8. So how much money has he saved now? Well, 8 plus 8 is 16, but we need to save at least 60, so I got to keep going. The third month, he saves another $8. Fourth month, he saves another $8. Now, if you are recognizing that this is just multiplication, then you can use division to help you solve this problem faster by dividing 60 divided by 8 and then interpreting that remainder as meaning we need an extra month. But if you want, you can continue going along this path until we get up to at least 60. So I'm going to continue on this path. 8 plus 8 plus 8 plus 8. So 4 8s. I need... Now the fifth week, he saves another $8. Well, I know my 5, so if I have 5 8s, that's the same thing as 5 times 8, that's $40. So we're still not up to 60 though. So it's the sixth week, he saves another $8. That's going to be 48. The seventh week, he saves another $8. So 48 plus 8, that's going to be 56. Not quite to 60, but if he has 56, that means in the 8th week, if we're adding another $8, that will put him over 60. And if we do our math, 8 times 8 is $64. The question was, how many months will it take him to save at least $60? 8 months. Because each one of these, 1 month, 2 months, 3 months, these represent the months, and $8 each month. And then we continued doing that until we had at least $60. And it took us 8 months to get over $60. All right, number 4. Ursula and Yi, I'm not sure exactly how to pronounce that name, share a submarine sandwich. So they're splitting it between them, or in some way sharing it. Ursula eats 2/8 of the sandwich. So I'm going to pull that information out. Here's Ursula, and that's 2 8s for her. Y eats 3 8s of the sandwich. So I'm going to put a Y for him or her, and that's 3 8s. How much of the sandwich do the two friends eat? Well, Ursula eats 2 8s, and Y or Yai, I'm not sure, eats 3 8s. So combined, we're dealing with 8s. 2 8s plus 3 8s would be 5 8s. Five eighths of the sandwich. Whoops. Okay. Number 5, a carpenter has a board that is 8 feet long. He cuts off 2 pieces. One piece is 3.5 feet long, and the other is 2 1/3 feet long. How much of the board is left? Okay, so we have 8 feet. I'm going to work on this problem over here. Actually, I'm going to work on it up here, so if you need extra space, because I'm out of space here, so I'm going to work on 5 over here. So he has 8 feet, and he cuts off 2 pieces. One of the pieces he cuts off. Well, if he's cutting something off, we know we're going to be subtracting here. So he's taking off 3.5. 3.5 feet. Oh, let me get that back. So I want to start with the fraction portion, and if there's nothing here, that's the same thing as having 0 halves, right? Because 0 halves would mean nothing. And can I take 1/2 away from 0 halves? Can I take 1 away from 0? No. So I'm going to have to borrow from this 8. So the 8 becomes a 7, and I borrowed a whole foot. And if I want to write a whole foot in terms of a fraction with a denominator of 2, a whole foot would be 2 over 2, right? So I now have 7 and 2 halves. 7 plus 2 over 2 would still be 8, so I haven't changed the value up here. But now I can subtract. 2 halves minus 1/2 is 1/2. Denominator stays the same all the way. And then 7 feet minus 3 feet would be 4 feet. And then the other piece that he cut off is 2 1/3 feet long, so we got to cut that piece off. And again, we're cutting off, so we're taking away 1/3. Okay. Now, we have different denominators here. So the first thing I want to do is change these two fractions to equivalent fractions that have the same denominator. And to figure out what I want that denominator to be, I have to pull out these two denominators, 2 and 3. Pulled them out, 2 and 3. And then I'm going to find the LCM, least common multiple. So multiples are counting numbers, so you're counting by each one, 2, 4, 6. I could continue on if I need to. 3, 6. Well, I'm looking for the smallest one, so I already have the smallest one they have in common. But again, I could keep going, but this is going to end up being my smallest number they have in common, 6. So 6 is the least common multiple. So I want both of these fractions to have denominators of 6. And then it's very similar to problem 1 over here, where we have to multiply. Whatever we multiply the denominator by, we multiply the numerator by the same thing. 3 times what is 6? Well, 3 times 2. So I multiply the numerator by 2, and I get 2/6. And then up here, 2 times what is 6? Well, we already figured that out, 2 times 3. And then I multiply this numerator by 3 as well. 1 times 3 is 3. Okay, so I now have 4 and 3/6 and minus 2 and 2/6. So now that I have the same denominator, I want to keep the same denominator down in my answer. 3/6 minus 2/6 would be 1/6. and then 4 feet minus 2 feet would be 2 feet. So my answer here would be 2 feet, 2 1/6 feet. Okay. Oh, where'd my mouse go? Okay, number 6. Jeff drinks 2/3 of a glass of juice. Write a fraction that is equivalent to 2/3. Well, this one's going to be nice and easy for us. We have 2/3. We need an equivalent fraction, and since it can be any equivalent fraction, we get a pick. You can multiply, as long as you multiply the numerator and the denominator by the exact same number, you can pick any number you want besides 1. So we could pick 2, 3, 4, 5, 6, 7, whatever we want. So let's practice. Let's just do 10 because we've been doing 10 a lot for these tenths and hundredths. So might as well get a little more practice on that. So I'm going to multiply the numerator and the denominator by the same number. And when we're doing that, notice we're multiplying by 10 over 10, which 10 over 10 equals 1. And if I have 2/3 times 1, I still get 2/3. So by multiplying by 10 over 10, which is equivalent to 1, I'm not changing the value of this fraction. So again here, I'm multiplying by 1 whole because 10 over 10 equals 1. So this new fraction is still going to have the same value as 2/3. It's just going to be cut into more pieces, 10 times as many pieces. So 2 times 10 is 20 for my numerator. 3 times 10 is 30 for my denominator. So that would be one example of a correct answer, but this problem has many correct answers. All right, thanks again for watching, and I will see you on the next video.